Let's talk about quadratic formula. Quadratic formula is a way to figure out the zeros, I'm going to add that here, of a parabola. That's the primary use. Now we can also use this to figure out the vertex, but the primary formula is used to figure out when a parabola is equal to 0. This is most useful when we can't factor and we can't use completing the square. And I would always use this really when there's a coefficient on x squared that's not 1 and I can't factor it out. This to me is the easiest way to find the zeros. Certainly factoring could be quicker, completing the square, but once you add this coefficient, this might be the fastest way. Okay? Now, our general way of writing a parabola is a times x squared plus b times x plus c. So in our case, a is equal to 3, coefficient on x squared, b is equal to 4, and c, I'm going to put just this, is equal to negative 5. The quadratic formula is right here. This can be proven using completing the square. It is just a modification, a generalization of completing the square. And you can see that it's a negative b, so change the sign of b, divide by 2a. And then because parabolas usually have two solutions, we put a plus or minus here. One where we'll add this term to get the most likely solution on the right, or we'll subtract to get the solution on the left. So again, if I could just sketch a picture of this, this first part, negative b over 2a, will give us kind of the middle or vertex of my parabola. And then when I add, I'll get this, and when I subtract, I get this. Now, certainly a negative on a could change that, but so this part, if I can highlight it, this part gives me the vertex, and this part gives me the distance from the vertex to the 0. So that's why I add to get one and I subtract to get the other. Okay, let's actually use this thing. Okay, so we've got negative b. So for us, that will be negative 4 over 2 times a. Now on the first pass through, all I do is substitute in the values. I don't do anything else. Square root of b squared minus 4 times a times c all over 2a. I should note here that we have a common denominator, so sometimes you will see this equation written, since it's both 2a, as one big fraction where it's like negative b plus or minus this square root of b squared minus 4 all over 2a. That's a great way to do it either way. All right, now I'm going to start simplifying a little bit. So negative 4 over 6 plus or minus 4 squared is 16 minus, let's see here, 4 times 3 is 12. 12 times negative 5 is negative 60 all over 6. So negative 4 over 6 is negative 2/3 plus or minus 16 minus negative 60, so plus 60 is 76 over 6. Now at this point, this tells us the middle. This tells us the distance, right? The middle and then the distance out to the zeros. This is quadratic formula. It's that easy. We could type this in and we would have our zeros where the graph hits the axis. One kind of prior skill that we had coming in was simplifying square roots, which might give us a way to simplify this fraction on the right. That is not part of quadratic formula to me, but you know, it is a prior skill that if you saw this on a standardized test, they would expect you to reduce this. So let's just remind ourselves that the square root of 76 can be written as the square root of 4 times the square root of 19, or 2 square roots of 19. So you could certainly, you know, say, okay, it's 2 square roots of 19 and 2 over 6 is 1/3, so we could write negative 2/3 plus or minus the square root of 19 over 3, like that. So just be aware, if you're taking a standardized test or something, they will most likely reduce that square root. Again, that's not quadratic formula. That's just prior algebra skills. Quadratic formula is just this piece right here. Can you use this? And again, you're finding where it hits the x-axis. This first piece tells us the middle x value, the vertex x value, and this second piece teaches us or tells us the distance out to the zeros. Let's do one more example. Negative 2x squared plus 4x plus 7. So let's just make a note that my A is negative 2, my B is 4, and C is 7. Those are my values I'm going to plug into my formula. So I've got negative B, the opposite of B, over 2 times A, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Now let's make a pass through where we clean this up a little bit. We're going to have negative 4 over negative 4. That's going to just be, of course, be 1. Then we've got 16 minus 4 times negative 2 is negative 8. Negative 8 times 7 is negative 56. All over negative 4. So we get negative 1 plus or minus square root of 72 over negative 4. And again, we're at the point where we've completed the quadratic formula. Like if I were to draw this, I could say, well, the vertex is 1 unit back because that's this value right here. That tells us me where it doesn't give me the y value, but it gives me where x was. And then this piece right here tells me, well, how far away are the 2 zeros from that? Okay, but we certainly could reduce the square root of 72 because that is the same as 36 times 2, which is 6 square roots of 2. So we could rewrite this as 6 over the square, or 6 times the square root of 2, and then of course 6 divided by negative 4. We could write negative 1 plus or minus 3 square roots of 2 over negative 2. And I should just say, you know, dividing by a negative changes the sign, but of course we already were doing this plus or minus out front, so we almost could just eliminate that and have the same answer. It would just almost reverse the order we find the answers in, but that's again beyond quadratic formula. That's just reducing and numerical reasoning here that, you know, if you add the negative or subtract the positive, like it's the same thing. You just find them in a different order. But this is quadratic formula, okay? This is a formula worth knowing. A is always the coefficient on x squared, B is the coefficient on x, C is the y-intercept, and plug this in. I'm going to, in another video, talk about the importance of this quantity under the square root called the discriminant, because certainly if this came out to be negative, we can't take the square root of a negative, so that will tell us that maybe, you know, our parabola is something like this where it doesn't actually have any zeros. Okay, I'm going to talk about that discriminant in a later video because that's really the most important part of this entire quadratic formula. It gives us a lot of information. If this video helped, please like and subscribe for more math help.